Hello 108 students, welcome to section 2.2 here. Mr. McHugh hanging out here with you to start off page 1, and we're going to deal with formulas here, and we're going to be doing this several times throughout the semester. So the skill we're going to be working with here is isolating variables when you have a formula that's got nothing but variables, and this can drive some students, give them a little bit of fits here, but hopefully I've got a couple tips here to help you out here. So a couple examples of formulas we're going to work with is distance equals rate times time. And notice, you guys intuitively know this when you get in your car, and if you're driving 75 miles an hour on I-84 and you're going eastbound towards Jackson, and you get in a car, you leave Boise and you go for 2 hours, 75 miles per hour times 2 hours gives you a total of 300 miles you would cover. Okay, and so we use these formulas a lot, and the key things remember is that formula is an equation with variables that describe a relationship of a real situation, of the connection between the actions of multiplying, adding, subtracting, or dividing that gives you these. Okay, so another one you might be comfortable with is P stands for the perimeter of a rectangle equals 2 times the length plus 2 times the width, and we're going to do an example down here. So hopefully you're comfortable with these. Interest that you earn on a certificate of deposit at the bank equals the principal, the amount of money you put in, times the rate that they'll pay you, such as like 0.5% because it's pretty low, times how long, T is time. So the amount that you invest times the rate that they'll pay you, like 6% or 0.5% times the time, will be how much interest you'll make on that amount of money that you've invested. Okay, so what we're going to work on here is solve formulas for a specific variable. A couple pointers here. Number one, ID stands for identify, not the state of Idaho. Identify the specific variable in the equation that you're supposed to isolate and use that arrow. This is my technique to keep my sanity. What variable are you trying to isolate? Okay, once you've identified that variable, treat all the other variables in your brain like constants. You can add, subtract, multiply, divide them. Your goal is to isolate the variable that you want. Okay, step number 3, use your properties of algebra. You go into your toolbox, addition, subtract, multiplication, division, combine like terms, distributive property. You're going to use those to isolate the variable. Okay, so let's take a look here. I got an example 1 here, and what we have is the perimeter of a rectangle is given. We said before, sorry, that's my phone ringing. Perimeter equals 2 times the length plus 2 times the width. What if they asked you to solve and isolate W? Okay, now the way I like to approach this is there's only one term with W. I've got my arrow on it here. What can I do to get it all by itself? 2L is a separate term, so we need to move it over to the other side by taking the opposite of addition. Class is subtraction, so minus 2L on both sides. Okay, so when you do that, 2L minus 2L is 0, and it cancels out, equal to 0, and there's your 2W down here. Now on the other side, the left side, you've got P minus 2L, and you write that P minus 2L and you stop. You cannot combine like terms, you don't have numbers, you don't have like variables, so you leave it P minus 2L. You have no other choice. Now you come back and go, what's my next step that I got to do to isolate the W? I've got the 2W term. To get W by itself, I got to use my decoder ring and undo multiplication via the opposite. So divide by the coefficient. Remember, that's a fancy term for the number in front of a variable, and you're dividing both sides by 2. Okay, anything divided by itself, I say it 100 times every semester, equals 1. Here's 1W equals, now what do you have over here? It was perimeter minus 2 times the length, all divided by 2. And you're done. You can't combine anything here. Now, some of you might look at this real quick and say, well, can I divide the 2 out of 2's? And the answer is yes. However, just be a little careful when you get equivalent answers here. And what I want to show you here is, let me just come down here and draw a line here. I want to show you that P every term up the numerator needs to be divided by 2. So this is equivalent. P divided by 2 minus 2L divided by 2. Okay, that is where a lot of students see this and then they realize that the 2 over 2 cancels out, and that's equivalent to P divided by 2, the perimeter divided by 2 minus the length, and that would also equal the W from the problem. Okay, so MyMathLab usually likes to see everything all under one divisor, so this should be the way you should take it. Okay, now this example over here, this is a little harder. They took the problem and they noticed from the reverse distributive property, you might remember this from back from chapter 6, the 2 and the 2 is in both terms. They pulled it out as the greatest common factor. This is an alternate way to do the problem. Times what's left, L plus W, and now that you've got that, here's the W term over here. I really don't care for this way. Divide both sides by 2, and now you've got P divided by 2 equals L plus W, but you know, maybe whatever floats your boat. Now what do you got to do to isolate the W? For the width, minus L on both sides, and look, lo and behold, you get the answer that I worked over here, P minus 2, P divided by 2 minus L. Okay, either way works, class, so you pick what works for you. Okay, that's it for here. We're going to wrap up page 1, so I will see you for page 2.